Hi everyone, it's Miss Haley again. For today's video, I'm going to be going over the 11.2.2 checkup for Algebra 2 on Apex, so let's get started. I'm going to try to go through this as quickly as possible so that the video is as short as possible, so I apologize in advance if it's a little bit long. So in this first part, we're labeling angles as acute, obtuse, right, or reflex. You should have heard of those first three, but a reflex angle is an angle between 180 and 360 degrees. Alright, so in the first one, this one's obviously less than 90 degrees, so it's acute. It's very easy to tell when we have a visual like this. The second one is definitely obtuse. Alright, now we're getting into just written angles, so we don't have that visual there. 200 degrees is bigger than obtuse, but it's less than 360, so that is a reflex angle. Alright. The second one, we're in radians now, pi over 6 radians. If you convert that into degrees, that's 30 degrees. All right, and a 30-degree angle we know is acute. All right, 160 is obtuse. And lastly, 5 pi over thirds is a reflex angle. I know that from experience, just being able to visualize radians, which you'll be able to do eventually once you get used to working with them. But if you convert 5 pi over 3 into degrees, you will see that I believe it's 300 degrees, but you'll be able to tell that it's a reflex angle. All right, next we're moving on to looking at DMS notation. So for these first two examples, we're in decimal notation, but we want to get it into degrees, minutes, and seconds. All right, so first I have 12 full degrees, so I know I'm going to have 12 degrees. Now I just have to figure out the minutes and seconds. So I take the 0.25, the leftover decimal, and I'm going to multiply by 60. So 0.25 times 60 is going to give me 15. So that is 15 minutes. So my final answer for this one is actually 12 degrees and 15 minutes. If I had an extra decimal when I multiplied by 60 for the first time, I would need to multiply by 60 once again to figure out how many seconds there were. But in this case, we don't have that issue. It's just 12 degrees, 15 minutes. All right, for the second one, I have 132 full degrees. Now I have to figure out what 0.45 is in minutes and seconds. So if I do 0.45 times 60 in my calculator, I get 27. So in this case, our final answer is 132 degrees and 27 minutes. Again, there's no extra decimal after 27, so I don't have any seconds to tack on to my answer. Next, we have degrees, minutes, and seconds already done, and we want to go back to normal degrees. So in this case, in number 9, I have 25 full degrees, and now I just have to figure out the decimal part. So instead of multiplying by 60 like we were doing in 7 and 8, we're going to be dividing by 60. So I'm going to take the minutes, which is 25 divided by 60, and if I do that in my calculator, I get, let's round to 0.42. All right, and now I'm going to have to do the same thing with my minutes, my seconds, except instead of dividing by 60, we divide by 3600. So 40 divided by 3600 gives me 0.01. So if I add these two numbers together, I get 0.43. So my final answer is 25.43 degrees. Now we're going to do the exact same thing with number 10. I have 80 full degrees. Now I have to figure out the decimal. So 50 divided by 60 for my minutes. Let's see what that gives us. That gives us 0.83. All right, and then I have to take the 18, which is my number of seconds, and divide by 3600. And 18 divided by 3600 will give me 0.005. So let's round that to 0.1. So if I add these two together, I get 0.84 degrees. All right, so now we're moving on back to talking about degrees and radians. So with number 11, I want to figure out how many radians 32 degrees is. So what I do is I'm going to take 32, and I want to have pi in my answer, so I'm going to multiply by pi over 180, All right, so first I'm going to do 32 divided by 180, which is 0.178, let's say, 178 pi. So generally when I was taught, this is how I would write my answer, but I think Apex wants you to multiply the decimal by pi, so you can just multiply by the pi button on your calculator if you have one, or you can do 0.178 times 3.14. All right, and that gave me 5.58 or 558 radians. All right, so that's my answer. All right, let's move on. 170 degrees, we're going to do the exact same thing. 170 degrees times pi over 180. So 170 times 180, or sorry, 170 divided by 180 gives me 0.94 pi. So you could either say 0.94 pi radians, or you could multiply 0.94 times 3.14, and that gave me 2.97 about radians. All right, so depending on what Apex asks for, you could either have pi in your answer, or you might have to multiply all the way through. All right, now we're going the other way around. So we're going to figure out how many degrees pi over 6 is. Pi over 6, we need to get rid of the pi, so we're going to multiply by 180 over pi. That cancels out the pi's when I multiply straight across, and I have 180 over 6, which is 30 degrees. All right, next I have 3 pi over 5. I need to figure out how many degrees that is. So again, multiply by 180 over pi. The pi's cancel. First, I'm going to do 3 times 180, which I get 540 over 5. 540 divided by 5 is 108, so that's 108 degrees. All right, hopefully those made sense. If you have any questions about converting with DMS notation or with radians, make sure you reach out, because those are some really important topics for pre-calculus as well. All right, now we're talking about arc length. Remember, arc length, let's call that L, or maybe you'll call it A, is equal to R times theta. And remember, theta has to be in radians. So if your angle measure or your theta is in degrees, you have to convert it into radians in order to find arc length, okay? So, number 15, the arc corresponding to a central angle of 35 degrees and a circle of radius 10. So we know our radius and we know our angle, but we need to convert our angle into radians. So in order to do that, that's what we just practiced. I need to do 35 degrees times pi over 180. So 35 divided by 180 is 0.194 times pi times 4 is 0.61, let's say. So I'm going to switch colors here. My arc length is going to be R, which is 10, times my theta, which is 0.61 radians. So my arc length is going to be 6.1 feet. All right, hopefully that made sense. Let's move on to number 16. In this case, we already have a central angle. Our theta is already in radians, so we don't have to do any converting. So my arc length is going to be my radius, which is 6 times pi over 3. So this is 6 pi over 3, which simplifies to be 2 pi. All right, let's keep going. All right, in this case, we're given the arc length, we're given the radius, but we want to find theta. So remember, arc length is going to be r theta, so let's do some substitution and see if we can solve for theta. So the arc length is 21.3. We already know r is 12, but we don't know theta. So how are we going to get theta by itself? We'll divide both sides by 12. So theta is equal to 1.775 or 1.78 degrees. Or I guess radians, actually. In number 18, same thing. So we're given the arc length, we're given the radius, but we need to find theta. So arc length is equal to r theta. Let's do some substitution. Arc length is 15, radius is 6, we don't know theta. So theta is equal to 15 over 6, which is equal to 2.5. And actually this one says to the nearest hundredth of a degree, so if this is radians here, we need to figure out how many degrees it is. So what we're going to do is 2.5 times 180 over pi. Sorry, just pause there. So let's multiply that through. 2.5 times 180 divided by 3.14 is 143 degrees. 143. That doesn't look like it, but it is. Alright, let's see. Number 19. The arc length shown is 7.5 feet. We need to find the radius. So, looks like this one got cut off. My arc length is 7.5, so 7.5 is equal to r times theta, which is 45 degrees. But remember, 45 degrees is equal to pi over 4. Okay, so we need to get r by itself, so I'm going to multiply both sides by the reciprocal, which is 4 over pi. Alright, that cancels that out, so r is equal to whatever 4 over pi is times 7.5. So if I do that math real quick, the radius is going to be 9.55 feet. Alright, so that's all about arc length. I think we have a little bit more about arc length. Okay. So in this picture, the measure of theta is 1 radian. We need to see if that is true or false. Alright, well let's see. So if our arc length is 2, our radius is 2.5, then let's see if when we divide, if we get 1 for theta. So we'll divide both sides by 2.5, and you can automatically see 2 divided by 2.5 is not equal to 1, so that's false. If it were true, then the arc length would be 2.5. Or your answer could be, or the radius would be 2, because we would need the arc length and the radius to be equal for the measure of the angle to be 1 radian. Alright, number 21. If the measure of theta is a radians and b degrees, then a is equal to 180b. A is equal to 180b over pi. So this is actually false, okay, because A would be equal to B times pi over 180. Alright, because if B is in degrees and A is in radians, in order to get B to be equal to A, we'd have to multiply by pi over 180 to get B into degrees, or into radians, sorry. Alright, number 22, this is our last one. Hopefully this hasn't been too long. Alright, so I have a picture of a clock here. I don't know if that was given to you, but it might be helpful to have a clock as kind of like a visual. We want to find the distance around the edge of the clock between 2 and 5, and we know that the radius is 5 inches. So looking at the area between 2 and 5, that's a quarter of the clock. So that's 90 degrees, right? And 90 degrees is the same as pi over 2. So if we want to find the arc length between 2 and 5, arc length is going to be the radius, which we already know is 5, times our theta, which we calculated as pi over 2. So this is going to be 5 times pi over 2, which gives me 7.85 inches. Alright, so that brings us to the end of this video. I hope it makes sense. Again, I'm going to be sending out the answer key to this on Thursday of this week, but hopefully this helps you prepare for your quiz regardless. So make sure to reach out if you have any questions, and have a great day.